Hello, everyone. Welcome. Hello. Hello, everyone. Welcome to today's session. I'm the only person in the studio right now, so I'm trying to be the admin and also take the session. So, give me a minute to check things out. Hello, guys. Welcome to today's session, and this is Ukeme. My colleague Imoh, who is meant to moderate this session, is currently not available, so I have to multitask and try to set up the studio, and also at the same time take the class or the session. So I'm trying to set things up. We would get to it in a bit. We'll get to it in less than, let's say, 3 to 5 minutes. Then we would start off. Thank you. Hello, everyone. Welcome, welcome, welcome. So, yeah, I see you, Dennis. I see you, Kennedy. I see you, Mafos Diallo. I see you, Dennis Musembi. I hope I pronounced your name. Welcome, welcome, welcome. Please let us know where you're streaming from or where you're coming from. Lagos, Abu Dhabi, Dubai, all around the world. Let's see to the chat. Daniel Ojo Williams, I see you. Welcome, welcome. Let's know in the chat where you're calling from, how are you doing, or where you're streaming from actually. How are you doing today? Then we would kick off as soon as possible. My colleague Imoh, like I said earlier, is not available at the moment. So I have to set up the studio and then do some other things and also take the session at the same time, which is a lot of work, you know. Jennifer from Lagos, Nigeria. Samuel from Lagos. Kennedy, my man from Abuja. I see you. I see you. Welcome, welcome, welcome. Ojo, where are you coming from? Daniel Ojo Williams. Where are you calling us from or where are you streaming from? Hey, Dennis is from Nairobi, Kenya. Beautiful. Welcome, Dennis. Welcome. All right, guys. So I will be taking today's session. My name is Ukeme David Eseme. your humble DevOps engineer at your service. Okay, so I would just Amarachi. Hey, that's my person. Oh. Amarachi, welcome. Oh. How do they say welcome in Igbo? Amarachi is coming from Enugu. That's my person. Oh. That's my classmates. Welcome. Thanks for the support, though. All right, guys. So today I will be taking introduction to DevOps, containers, and serverless computing on AWS. Let's get to it. This is my slide. Push this down. Cool. Good. So introduction. Temi Tokpe from Lagos. Welcome, Temi Tokpe Agbola. I hope you learn a thing or two about DevOps today. So DevOps is a very interesting topic, and sometimes some people who are already developers do not know the importance of DevOps until when they want to deploy their application. That's when they know that DevOps on its own is a different field entirely, and it's very important in the sense that as a developer, you have an application that is running on local host, which is on your computer, yeah, it works, but then you want someone else to be able to access that your application. You want that application to be globally accessible, and then you find out that it works on your computer but it doesn't work on other people's computers, and you start to ask yourself, what's the problem? Why is that so? That's where DevOps comes in. DevOps basically helps with deployment. Um, we would DevOps would help you with provisioning infrastructure in the sense that we create an environment, a consistent environment where your application can thrive. And then we kind of like create a workflow, which is a pipeline for other developers to work on the same projects. And then we help with releases in terms of quick release. So back in the days when people develop, it takes a long while before they go into production stage or they release their product. Okay. I'm actually saying I can testify to that. I learned the hard way. Yes. Yes. So where was I? So with DevOps, yeah, you can release almost quick releases. You can release and deploy almost every day. You can also test while before you release. You can also automate your testing, check if everything is working. In fact, the entire process of from a Git commit to building the application, to testing the application, to deploying the application is a whole process on its own. And with DevOps, you can literally automate most of that and then go to sleep. And then your application is running, but you need to get metrics. Okay, how is this server doing? How many people are visiting? Why is one section of the application working and the other isn't working? We can also put something called monitoring in that entire pipeline. So we monitor it, get metrics in real time, and all of this is happening in real time. We see that there's a flaw somewhere. We've automated testing, we've automated monitoring, and immediately the system would inform you that this is going on, this is the problem, you know, quick fix, let's work on it. You work on it and immediately is in deployment, or well, not immediately, but in a very short period of time is in deployment. So there's a whole process with DevOps, which is very, very interesting. And if you want to get into DevOps, and when you start working on terminals, you start working on a server, building servers, configuring servers, you know, it gets very, very interesting. So let's go into it today. So we're doing introduction to DevOps, containers, and serverless computing. People say serverless. What does that really mean? We'll get to that. Um, so the next slide, this is a lot of words here, but I'll just skim through it. Is an overview of DevOps. So DevOps, containers, and serverless computing are three essential components of modern software development and deployment. DevOps combines software development and IT operations. That's the dev, which is the development, IT operations, which is the ops. So DevOps, promoting collaboration, and efficiency through continuous integration, delivery, and deployment. So that's CICD, continuous integration, continuous delivery. All right. Sounding more interesting now. Don't worry, we'll get to practicals. Then containers. What exactly is a container? So containers provide a lightweight and portable way to package your applications and their dependencies, enabling scalability and resource efficiency. What does this mean in layman terms? So basically, when you finish building your application, what we can do to solve that problem of, oh, my application is working here, it's not working in this environment, this person can access it, this person can access it, is to package all of that application, package everything into something very lightweight that has majorly the binaries and the things that it requires to run. We package it, yeah, and then put it somewhere in a registry where other people can also access it. You get, so we're saying package the applications and their dependencies. We've covered that. Enabling scalability. Now, the scalability part is where cloud comes in most of the time. So you have a website or an application which is enterprise level. You have close to like 5,000 people hitting that site. This site is running on two servers, let's say an EC2, two EC2 instances. At some point, it's going to get to a max. That's when you start seeing that, oh, this site is crashing. Jump site is crashing. It's because they don't have auto scaling, or a bank website is not reachable. Sometimes it's because they don't have auto scaling. So with auto scaling there, once the system notices that, okay, the threshold for two EC2 instance, which is the server, is 5,000. Once it gets to 5,001, 5,002, what the system would do intelligently is to create another server to accommodate that. So that's when you're scaling up, right? You're scaling up, create another server to accommodate that. And then when you have less peak periods, let's say, for example, out of like you're having scaled up because you have like 7,000 people hit your server, and then in the night you have less people hitting your server, so you have like, let's just say, 2,000 people on that server. It's going to scale down. So there's no point. That's why cloud is better than on-prem. On premises, once you've provisioned that three servers, you keep paying for that, whether you're using it or you're not using it, you keep paying for it. But with cloud, yeah, it would scale down to the the amount to accommodate the amount of traffic that is there at that point. So it means you had three servers before, it scaled down, two is out, you're no more paying for that two. You're now paying for one. When the peak period comes, it scales up, you pay for what you use, basically. So resource efficiency, that's what I just explained. So the next slide. So what's serverless computing? Is an abstract way sorry, it abstracts it abstracts away infrastructure management, allowing developers to focus on writing code and automatically scaling resources based on demand. I've explained that automatically scaling resources based on demand. But what does it mean for those who are new to dev? When it says it abstracts away infrastructure management, when you say you have a serverless infrastructure, what that basically means is that you are not managing the servers. There's no point for you trying to be an admin, going back to the back end and checking what's going on, what's breaking. Okay, it's time for us to scale. Let me go and manually scale it. No, with serverless computing, AWS or the cloud provider manages your infrastructure for you. That's why AWS is good. They take away the load for you, and manage those servers. That's what it means by serverless. So together, these technologies revolutionize, that's DevOps, containers, and serverless. These technologies, when you put them together, they revolutionize software development by streamlining processes, improving scalability, and producing operational complexities. You know, that's operation reducing operational complexities also is like managing that server is a complex thing on its own. Doing some automation is also a complex thing on its own. So it reduces that operational complexity. Next slide. So DevOps on AWS. This is an overview of basically a CI/CD pipeline, right? I think I covered this 2 weeks ago. Yeah, I did, but we'll go again on this. So this is the process. If you know this, you've almost known DevOps. It's not like you've known everything, but you understand the software development life cycle of a DevOps engineer or a project when you're doing DevOps. So it starts with the author, right? The author basically is an IDE, for example, VS Code, right? But with AWS, we have a product for everything that's in the market space, almost everything that's in the market. So our own IDE is called Cloud9, right? We'll check this out later. Our IDE is Cloud9, so it starts with auto writing your code. Then the next process is source control. Source control, GitHub, right? You're pushing your code to a single place. Oh, bank is from Guinea. Welcome bank. So yeah, we are pushing your code to a specific source of truth. Do you get? So that source of truth is your GitHub in some cases, in most cases, or Bitbucket. But then with AWS, we have code commits, right? So the next stage is now the building stage. We have AWS code build. This would help you build your application, right? The next step now is testing. So in code build, you can integrate some other third-party softwares to help you run your testing, right? If you are already in DevOps, you should know Jenkins. Jenkins is also a CI/CD tool. Jenkins is a very popular CI/CD tool, and that's with Jenkins you can add plugins to do most of all of these stages or all of this these stages actually. So you can do your testing on code build using a third party. Give me 30 seconds, please. All right, so that's for testing. Sorry about that. So the next stage is the deployment. So with deployment, we use AWS code deploy to do our deployment. In some cases, people use Argo CD to do deployment. Some people also use Jenkins to do their deployment. And then the next thing is to monitor. And then with monitoring, you can use CloudWatch. So CloudWatch or Prometheus or whatnot or Fluent D. So these all of these are logging logging resources, should I say logging services. They help you log information, and then that lets you gives you information of what is going wrong or what you're performing at best. You use that to get your metrics. So this is the cycle. So if anything breaks in between, it's going to give you feedback, and then you go back to the beginning, which is auto. You have to now check the code and then make the adjustment. Immediately you've made the adjustment, you push to GitHub, it is going to automatically trigger an event, and that event just takes you throughout the entire process. So the next slide, I hope you get that. If you have any questions, please put your questions in the chat. Let me know if you need me to take anything or explain anything. All right, so containers, yeah, we're back to containers now. The concept of containers and their advantages in software development. So containers are lightweight, yes, stand alone and executable units that's of software that package software and its dependencies, enabling consistent, underline that consistent, enabling consistent deployment across different environments. So the best thing is that package your application as a container. That was the first that's the first step of solving the problem of, oh, is working here, is not working here. Right. So what are the advantages? Portability, I just explained that right now. Scalability, I explained that also. You can scale up, scale down to accommodate Resource efficiency, you are basically using the binaries that are needed. If you write your Docker file well, eh, you will reduce the size and only the necessary binaries that are needed to make the application to run is what's going to be there. Instead of the traditional way where you've done npm install, and then there's just a bunch of packages. Your your application is not resource efficient, right? If that best puts it. So the next thing now is isolation. So when we say isolation, it basically means, okay, I've packaged this thing and I want it to run in an isolated environment, which is the container, right? Reproducibility. So that basically means, okay, if I've run this application now, I can create multiple instances of it. I can create multiple instances running on different ports, and they're all running at the same time. Unlike local host, where if you've let's say you do npm start now for those who write Node.js or Node. If you do or React, if you do npm start now, you basically will just define a port for you. Let's say port 5,000. You're running on port 5,000, and that's it. But with in terms of reproducibility in in a container, you can basically reproduce that particular application in another container, make whatever changes you want to make, and then put um, um, uh, upload it to a specific port or open a specific port where people can access it. Do you get? You can do that multiple times. So you have like 5 or 6 versions of the same application running with specific different modifications to each of them. I hope you're with me. Please let me know if you have any questions. Continuous integration and deployment. Containers facilitate streamlined CI/CD processes, right? I've mentioned that already. Versioning and rollback. Yes, so I mentioned something that sounds like versioning. So if I have this application running in an isolated environment, version 1, I make another change in my source code. I push, build everything, create the container again, version 2. Version 1 and version 2 can still be running at the same time. But the point is, you have 2 versions. So if there's something wrong with the latest version, you can always roll back to the previous version. So those are like key takeaways and advantages of using containers. There's a lot more. In practice, you will see that, man, this container thing, man, you get the point. So next, yeah. So containers on AWS, right? So this chart is showing you AWS services, container services. So container services, service combination on AWS. On the left hand side, we have the EKS tree. On the right hand side, we have the ECS tree. I'll explain what those acronyms are. So on the left hand side, EKS basically, we'll start there, the left hand side. EKS basically means Elastic Kubernetes Service. So what is Kubernetes? Yeah, Kubernetes is a container orchestration service or a container orchestration tool. What does container orchestration mean? If you have a microservice architecture, for example, Netflix runs on microservices. Microservices in the sense that your application is loosely coupled, in the sense that you have your database as a microservice, you have your login, just the login part as a microservice. You have your home page as a microservice. You have your header as your microservice. You have your every single component. You break that down into different services. For e-commerce now, you have a microservice that handles checkout. You have a microservice that handles payment. You get, so if the reason why it's like that is for reliability. If one of those services is down, doesn't mean your entire application should crash. Amarachi can testify to this. When we're working on a specific project, and then you write some code and something just goes off, In a monolithic application, everything is going to crash. Application will not work. It's going to spit out errors. But in a microservice, the error is peculiar. How do you pronounce it? Peculiar to that specific service that is down. So if checkout is not working, that doesn't mean the e-commerce website should go down. That doesn't mean the login should not work. That doesn't mean profile should not work, right? So David covered microservices yesterday. Going back to this chart, I went on a spree there. Going back to this chart, Elastic Kubernetes service, which is EKS, is a Kubernetes is a container orchestration tool. So it manages each microservice as a container, right? So this is the version that AWS has. This is AWS version of Kubernetes, EKS. That's why they wrote orchestration tool there on the left hand side. So when you're using EKS, you have to create, when you're using Kubernetes in general, you have to create cluster, a cluster where your application is going to live in. Now, what is that cluster? A cluster is basically a collection of servers, right? So, in creating those collection of servers, there are two types in AWS. There are actually more than two, but EKS is using these two primarily. EC2, we know what EC2 is a server, and then Fargate, we know what Fargate is. Fargate is also a server, but it's serverless. Fargate is serverless. Like I said, serverless, you are not managing the servers. It's just AWS has provided that management for you. AWS is going to manage it for you. So your job is just to code and deploy, right? So EC2 is not managed, it's not serverless, right? So those are the hosting types. You can use this tool to create your cluster. So on the right hand side now, we have the orchestration tool of ECS. What is ECS? ECS is basically Elastic Container Service. Remember, EKS is Elastic Kubernetes Service, right? ECS is now Elastic Container Service. Okay, so with ECS now, ECS is basically synonymous to, should I say, Docker? Yes, if you know what Docker is a container service. It creates containers out of your application. So that's like AWS version of that, ECS. So it helps you create that abstraction of an isolated environment which is a container basically for your application to run. So the same hosting type, uh, EC2, which is a server that is not managed, Fargate, which is a server. Okay, there's a question from Kennedy. Let me see if that will show here. Um, hold up, hold up, hold up. Oops. Yeah, so there's a question from Kennedy which says, what's the difference between EKS and ECS? EKS is using Kubernetes. ECS is a container service, something like packaging your application into a container, like Docker, creating a Docker image out of your application. I hope that answers it. So EKS is Kubernetes, ECS is container, Kubernetes and Docker, right? Okay, so next slide. AWS container options by layer. I hope you can see this. This is possible to okay. AWS container options by layer. So these are AWS services that you can use to create containers, that you can create containers out of or have some form of affiliation with containers. There's AWS App Runner. So this is the first assignment. This is the first quiz. Anybody who gets this would The first person to get it will get the $25 AWS credits. Define AWS app runner. That's the first one. So moving on, AWS app runner, AWS Elastic Beanstalk, Amazon Light Sail. That's the first quiz. Oh, define AWS app runner. So these three now are basically provisioning services. You use these to provision. Give me a minute, please. Give me a minute. So there's nobody's answering the question. You don't want $25 AWS credits. So the on the top layer is what we use to provision servers, right? On the second layer is the orchestration layer, which you have the ECS. We've explained that. EKS, we've explained that. ROSA is Red Hat OpenShift. And then on the lower corner is the capacity layer, where you have Tolu Orina. Let me put that up. So Tolu is the first person. He's always getting all the $25, and he's going to get this one. So AWS, what's this? All runners. It's not all runners, oh, it's app runners. Oh. AWS all runners is a container application for containerized applications without prior infrastructure or container experience. Uh, yes, but it's AWS app runner. It's not all runner. So Uh, so Tolu gets it actually. So Tolu gets the credit. All right. So we've covered this now. We'll get to practicals very soon. There's no time. So serverless computing on AWS. Serverless computing is a cloud computing execution model where developers can focus solely on writing code without having to manage the underlying infrastructure. We've covered this before. Tochukwu Okpara, welcome. So, what are the benefits of serverless computing on AWS? We have event driven infrastructure. So, serverless computing follows an event driven model where functions or services are triggered by specific events or requests, right? So, functions start when there is a trigger. So, when something happens, something else should happen, right? So, event driven architecture. Automatic scaling, I've mentioned this before. Service serverless platforms automatically scale the resources associated to execute functions based on the incoming workload. I'm sure you get that. I'm just trying to speed this up so we get to practicals on time. Pay per use pricing. With serverless computing, users are billed based on the actual usage of resources rather than pre-allocated capacity. So this is the thing about on-prem and server. So we on-prem, you pay upfront, and whether you're using the service or not, you are still paying. But with serverless and AWS cloud computing, you pay for what you use, right? So no server management. I said this before. You would not need to manage your servers because it's serverless, right? So serverless doesn't actually mean there's no server. There is a server. It's just that you are saying managing it. AWS will manage it for you. So this is serverless computing workflow right now. So in AWS, we have two very popular serverless services. Remember, EC2 is a compute service, EKS is a compute service, right? These are CPUs. So in terms of serverless, we have Lambda. Lambda runs code to retrieve local information. So with Lambda now, Lambda only runs majorly they use Lambda for event-driven applications. So if nobody is hitting your servers, there's no point for the Lambda to run. It's when there's a request, as when it now runs. You get so if there's nobody visiting your website, which you use Lambda on. It won't run until someone makes a request. Do you get? So that saves costs. So this is the workflow. S3 bucket, you put your front end static website on it and an S3 bucket and then host it. And then when the user clicks to get information, it's API gateway. API gateway app makes a REST API call to the endpoint, right? So once it gets the API call to the endpoint, that sends a message to AWS Lambda, which runs the code. Lambda runs the code to retrieve the local information, and possibly in that code is saying that you should go straight to a DB to retrieve information, and then it goes to DynamoDB. DynamoDB is a NoSQL database. It's a NoSQL serverless database provided by AWS. So this is our NoSQL serverless version. You know, um, it is a counterpart to MongoDB. MongoDB is also NoSQL. I don't know if MongoDB is serverless, but this is what we use at AWS. So DynamoDB takes the data and then pass it back to Lambda. Lambda passes it to the API gateway, and then it shows on the client screen, right? So that's it for this. So what I'm going to do now, we'll quickly do a quick practical, and we would what do we want to do today, sir? Let's uh let's work with containers, because if I say we should do CI/CD now, that'll take a lot of time. Let's create a container that runs a simple server. Any cons for serverless computing? Well, right now there are cons. There's nothing that doesn't have a con, right? So right now, there's this battle going on in terms of if you should actually use serverless. Sometimes some people who use serverless and they don't like properly design the architecture, they get bottlenecks somewhere around the architecture or in the application. They get bottlenecks and then they start paying more than they should. You know, I think 3 weeks ago there was AWS made an announcement about them going back to rethink about the architecture around serverless, and people were scared that, oh, we've removed our application from monolithic to a serverless um, format or infrastructure or architecture, and now you're telling us to go back. Do you get? So there's still talk around that. You can do some research on the cons, but I can't really pinpoint case studies right now from the top of my head. So that would be the second quiz to get another $25. So Tolu or Ina, you are not participating in this. You've already gotten one. So find out the cons for serverless computing. Post them in the chat. First person who does it gets $25 AWS credits. Okay, so I'm gonna try to share my screen right now. Um, I'm gonna try to share my screen. Okay, so what I'm gonna do is, like we said, we want to create a simple container, right? In a server, create a simple server container, right? We use Docker. So, wow, two applications running here. Let's see. Hmm. Okay, so I'm just basically going to create a new EC2 instance. To create an EC2 instance, you log into AWS. On the top right hand corner, you or the top hand corner, you see services. Click on services, scroll down to compute. This is compute. You see EC2, click on that. It takes you to this page, right? Yeah, so this is the EC2 dashboard. Yeah, so on the left hand corner, you click on instances, and then on the top right, you see launch instances. So I'm going to launch, click on that. Let's create a sample server. So in this sample server, we want it to run Ubuntu 20. We've done this before countless times, but why not do it again? This time I won't be using T2 micro. T2 micro is free tier, so we're creating the instance type. We'll use T3 small. T3 small gives you two virtual CPUs and 2 gig of memory. We pick that. And then you create a key pair. I already created one before, so I'll just use that. I think DevOps back. So leave every other thing as default. No, wait. Um, yeah, create a security group. This we've checked this. It allows SSH, which is port 21. Allow HTTP. Yes. And then scroll down to the end. Launch instance. Let's see if we can do this in less than 8 minutes. Um, Lack of control over infrastructure. Ah, it lacks customization. Okay, we'll come back to that. Yeah, so we've launched our instance. Now let's go into this instance and create a Docker, install Docker there. So click on connect. I'm going to use EC2 instance connect. We have like 8 minutes. Uh, okay, so we're in this instance right now. What we'll do is to apt update. So it's sudo app updates. Sudo. Oops. What am I writing? Sudo apt updates. Yeah. Let me zoom in a bit. Okay, we've done that. The next thing is to install Docker. So we say no. The next thing is to change us to a root user. So let's do sudo dash I. Aha. Why is it slow? Sudo dash I. Now we need to install Docker, or before we install Docker, let's install Apache. So if we installed, so Apache is a server. So we install Apache. Now I'm just going to create something very simple. I'm going to echo um this is a server, and then I would put that inside a file called index.html. So if I do ls, should have that file there. I can cut index.html. So I see this here. This is a server. Okay. So I can now um, move or copy index.html to a file, an Apache file. So I'll say that sorry, to an Apache folder which is in var slash www slash HTML. Oops, so it's index.html. Can't spell M. Yeah, so if I go into this folder now, I should see that file there. So if I do cd slash var slash html by ls at index.html, so the file is there. So now what I want to do is to make sure this is showing on the server. So let's see, first of all, see if Apache is running. So service Apache to status. So it's showing that Apache is running here. So let me first of all, let me check the security group for this instance. So where is that instance? This is it. Let's check the security group. Check the inbound rules. So we have this port open. We need to create a port for port 8080. HTTP port 80. Okay, we've already, this is it here actually. So I'm going to cancel this. Yeah. So what I'm going to do now is I will take this IP and then so we see that this now we've created a server and this is the server is running. If I modify that file, if I say ano index.html and then add something to it, if I add my name is Ukeme David Eseme, put a smiley to it, and I save. Let me cut it to see. Yeah, so it's there. If I come back and refresh it, see, so that works. So what the last thing I'm going to do now is to install Docker and Dockerize what's going on right now. So I'm going to how do you install Docker? Apt install Docker. We're already out of time. We have 2 minutes. Let me see. Docker. So Docker dash v. Oops, so it's apt install docker.io. We have 2 minutes. Hopefully we get this done. See if there's any questions. I'm trying to moderate and also take the session at the same time. So it's very difficult for me to concentrate on one thing right now. So let me check if Docker is installed. We have Docker installed. Now we can Docker install Docker. Let me see Docker images. We don't have any images yet, so we create a Docker image. Docker pull Ubuntu. Let's pull in Ubuntu. It's getting the latest version. So if we say Docker images, you see that there Ubuntu is running. So let's create a container out of that. So we would do Docker run dash integrated terminal in detach mode. We want to run the Ubuntu latest and then in a bin slash bash environment, right? So if we do Docker ps See this container is running, so we want to go into that container now. How do we do that? I'll bring this back up. I think it's Docker exec. Yes, exec. Um, yeah, so this here is supposed to be the container ID. So I'll take 7CF4. I'm getting it from here, container ID. If I do this, oops, no, Docker, because I added this T here, sorry, this D detached. So if I do this, yes. So now I am inside this container. Wow, we've spent time. Let's quickly rush through this. I'm inside the container now. You see 7CF. So now I'm going to. Sorry, guys, I was out for a bit. Please let me know where I stopped, or where was the last place you had me. We have to finish this thing. So let me go back to this. Um, let me go back. So here we're inside the container now. I'm going to install. Okay. Uh, okay. This is what we'll do. Let's connect back. We have to finish this. We spent excess time. We have to finish it. We'll finish it. So I'm going to connect back. I lost. Okay, we're already back here. So I do Docker images or sudo dash I Docker images. Okay, so we still have that Docker PS. Still have that. Let's get into that container now. So it's Docker exec integrated terminal 7CF4. So that's the container ID. And then we want to do a bin slash bash terminal there. We're inside now. So if we want to install Apache, so it is apt install Apache Apache 2. Okay, so this is red apt get install Apache 2. This is weird. Okay. Hmm. Okay, so we would because of time, we would basically stop here, and this is it. We have a DevOps group. If you want to continue learning DevOps, we have a DevOps group I would advise you to join. I am going to I'm going to send the link, put the link in the chat so you can join. Okay, so here I'll stop sharing my screen for now because I'm trying to get the class and then moderate at the same time. So we need a winner. Amarachi says cold start latency. Serverless platform typically spins up a new instance or function and then sounds like ChatGPT all to the end. And then we have Kennedy, who is the first. He says the serverless architecture lacks customization. That's the con. Samuel Ekele says lack of control over infrastructure, which is the same thing, Kennedy, as you said. Um, Daniel Dongo, I think I should be showing this thing. So Daniel Dongo is saying cons of serverless architecture, security of the architecture, complexity of the setup, less effective for long processes, difficult to test replication of the production environment, less okay. Kennedy again is saying like the serverless architecture cannot be customized by the customer since everything is managed by AWS. Same thing. And then Amarachi posted this very long. So we'll read some of it out, which is also correct. Cold start latency, serverless platforms typically spin up a new instance of your function when it receives a request. If the function has not been recently used, there may be a delay known as a cold start. So everything here is correct. But the first person is basically Kennedy, which posted this. Sorry, this is what Kennedy posted. The serverless architecture lacks customization, which is basically it. Because it's serverless, you can't customize it. So we'll stop here for today. Um, Kennedy and Tolu Orina will reach out to you for you to get your $25 AWS voucher. Thank you, everyone. Thank you, everyone, for coming. Please let me know if you have any questions. We'll quickly take those questions and then we'll call it a day. Any questions? Okay, I'll take that as no questions. Thank you, everyone, for coming. Please join the AWS DevOps WhatsApp group. We work on um, practical projects. Work-based projects. We teach you how it works, how everything works. Work on them together. I have sent the link on the WhatsApp. Join the group. Sorry, on the chat. Join the group. Thank you, everyone, and please have a wonderful day. Thank you.